Hi, everyone. Today let's talk about how the semantic intelligence from vLLM actually works. Yesterday we took a research point of view on how this like proof of concept works, how we can route a request to a particular model with a better intelligence. So now let's see how it's implemented. So the core idea behind the implementation is using the Envoy proxy. So Envoy proxy is right now is kind of a gold standard for containerized applications. So every containerized application will have its sidecar Envoy proxy where it's responsible for handling its traffic and applying any external protocol rules or anything. So whenever you hit a node, uh, you go through a node which is running a service A. The service A will have its Envoy sidecar, which is responsible for managing the internet traffic. So let's go through. So few things here are the repository, the work that vLLM implemented is primarily in Go. Whatever the components that are attached to Envoy proxy are written in Go, since Envoy proxy and the Kubernetes, most of the implementation is in Go. So to stick with it, they went with Go. And the communication protocols were strictly gRPC for the external protocols in Envoy proxy. So the only choice left was to use gRPC. We can't use JSON, and since Envoy proxy is a very quick request routing and like a kind of a tester, you need to have gRPC. We can't afford to go with JSON and do a heavy load there. So yeah, already we talked about why we were using Go. Since we are handling with Envoy proxy, Envoy proxy itself is in Go. So to extend the Envoy proxy capabilities, we had to VLM does use Go for uh, rest of the work there. So that was the choice for the Go. And as we all know, Go is kind of uh, has a good support for concurrency, and it's a very strictly typed language, and there are very less chances of getting any inference time bugs. So coming to the Envoy proxy, so I explained what Envoy proxy is. It's a sidecar which sits beside the application and handles most of the network of the application, and it routes. So each application will have its Envoy proxy, and the uh, communication between multiple microservice applications is via Envoy proxy. Each they communicate from one Envoy proxy to another Envoy proxy. So that's the high level Envoy proxy definition. So Envoy proxy does has a lot of inbuilt capabilities for managing rules, but here in case of our routing challenge, we are actually doing a semantic routing, which is kind of not inbuilt in Envoy proxy. Or if you want, like for these specific scenarios where we want to have an external routing decision has to be done in the Envoy proxy, we can make use of the external proxy, which is short form, like the short form is ExtProc, which is basically external proxy. So what Envoy proxy does is it calls the external process which is responsible for the uh, request. It will call the that service, and it will wait, and if the service is uh, successful, it will go ahead with the next steps that it has to do. So basically to share the traffic with its source application. So yeah, so here the main abstraction was from the external proxy, and uh, external proxy is in gRPC. So the communication between the external service and the Envoy proxy is in gRPC to have the JSON overhead not being there. So this is on a high level what internally how the request flow goes through and how it's being written. So here are few new concepts to me also. So let's go through the Go documentation, the Envoy proxy documentation in a thorough way. Uh, so yeah, this is my first time looking at Go. I know what Go is, but I never looked at it. So let's read through the major sections. So let's Go is a general purpose long language designed with system programming in mind. It's strongly typed on garbage collection and has explicit support for concurrent programming. Yeah, which kind of makes sense with what the Go's philosophy is. It's like a better programmer-friendly language than C++. You don't need to like really uh, debug C++ level code, but uh, it provides more from a package point of view. So in Go, I think everything is a package. Programs are constructed from packages whose properties allow efficient management. So this is the abstraction I think the Go has. So everything is a package. You need to write a package to go ahead and do something. I think that was compact and simple to parts. We'll get to know in later stages. Mm, yeah, so I would highly recommend anyone interested in Go to go through the Go dev guides. I'm just going through it. Let's see what Envoy proxy is. Envoy is a layer 7 proxy and communication bus designed for large modern service oriented architectures. So let's see what the problem without Envoy is. In practice, achieving the previous stated goal is incredible. Like this is the goal. So the network should be transparent to the applications. When a network and application problems do occur, it should be easy to determine the source of the problem. So without this sidecar Envoy, like each request has to go through the entire service itself. So there is no separation, like the load, the traffic is directly hitting the server. And when in micro service architectures, there are mutual requests going between the servers. So this kind of makes it a very high request pool, and it really becomes hard to debug where actually the fault is. So separating the request and network layer from the application logic and the business logic is important. I think that's what Envoy brings to the table. It runs as a sidecar to the main application where the developer can focus on the business and the application logic on the main application, whereas Envoy handles most of the networking. So this is on a high level what Envoy supports. We can go through it. Yep, that's all for today. Uh, so just a high level diagram. So on Envoy. So when a request comes to let's say in our case we have the API gateway for the models. We have a service which runs. We have a API service which kind of routes the request to all the models, and we are basically deciding what routing is. So that's the goal of semantic search. But here we have the Envoy. So let's take the API gateway as a service. We have the Envoy sidecar running next to it. So any request coming to the API gateway should flow through the Envoy, and Envoy will forward the traffic to the API service. So here Envoy does act as a load balancer, and the not a basic load balancer. It can do other things. So coming to inside of Envoy, so Envoy has its own capabilities, but in our case we have the semantic routing as external process. So how we can do this? So when a request flows through an Envoy service, it will send the request if there is a interrupt and we need to call external service. It will send the request to the external service. It will wait for its response, which is in gRPC. Once it gets the response, it will continue with its process, and if there is any more interrupts, it will call the external process and wait for the request and until the state ends. And once it ends, so it will forward the request uh, the next state that uh, the flow is choosing. Yep, that's all for now. So tomorrow we'll be having a hands-on session on the semantic routing. So we'll try to see how semantic routing works from both a code point of view and evoking demo point of view, whether actually it works or not. And we did talk about the shortcomings of the semantic routing, as noted by them as well. The since semantic routing is a per request based process, so we are only taking the user's request as the whole optimization problem. We are not so, but in the real world scenarios like a coding agents, here we are actually dealing with sessions, and uh, switching a model in between a session when there are there are problems. We go deeper into what those problems are and whether like the current semantic routing is sufficient or what all it needs. We'll go deeper once we have a working session tomorrow, and we'll build more on this. Yeah, thank you.